Hello everybody and welcome again to your channel Thermal Engineering Concept and the Principle. In a series of episodes, we are going to introduce the concept of condensation and how to deal with it, whether it was a condensation process over or inside vertical and horizontal tubes. How can we estimate the heat transfer coefficient for condensation of fluids as they pass over the outer surface of tubes? Let us go through the details of this episode. Welcome, my friends and colleagues and followers. The condensation process is one of the important topics present in modern industrial applications in the field of energy and heat transfer. We may find the condensation process in many topics and fields of industry, such as petrochemical factories, refineries, food industry, power plants, air conditioning and refrigeration, and many other topics that is experienced in the field of thermal engineering. The prediction of condensation process and the performance of a heat exchanger is mainly based on the heat transfer coefficient and how accurate it has been predicted. Condensation can occur in different orientations: vertical, horizontal, single, or tube bundle. And in the present episode and the film episodes and videos, I will introduce the condensation process in different categories, whether it was external or internal flow. Thank you for your support and continuous assistance that is afforded by your side to the channel. And let us go directly to the objectives of the present episode. The objectives of the present episode are concept of condensation process and how does this process occur on a single horizontal tube and tube bank with some illustrations for such topic, and then we will go to the closure. It is a quite a short episode, but it presents an introduction for the condensation process on a tube bundle that will be covered as well in a second part for this subject. A concept of condensation process on a horizontal tube, in a way, from the physical point of view, similar to that of vertical tube, with some principles uh, and some different points, of course. We can't describe it by explaining this process on this illustration. Here we have a horizontal tube where cold water is passing through the uh, tube, and then we have a vapor flows outside the cooling surface. The temperature at the surface is uh, less than the dew point of the flowing vapor, and it is colder than the bulk of the fluid. Then the molecule of the vapor, the substance, will be closer to each other and a coalescence will occur. Then condensation process will take place. Of course, the condensation forms sometimes a thin film on the cooling surface, and due to gravity, this thin film can be washed away, and periodically, regular regular removal of this film from the cooling surface, then the condensation process will continue to uh, proceed until as long as we have a continuous operation or process. The concept of condensation on a horizontal tube bank can be described by these illustrations. The vapor flows perpendicularly on the outer side of the tubes, horizontal tubes, in a bundle, and cold water, for example, passes through the tubes, the inner side, and in this way, the condensation process can be accomplished. The condensate from the top row moves to the second row and continuously the condensate flow from the upper row to the lower part of the condenser. And as we move from the top side where the vapor enters the condenser to the center of the bundle, we may find that the heat transfer coefficient is reduced in that direction. It means that the upper row is usually possesses the highest heat transfer coefficient, and the lowest value can be experienced in the lower tube rows. And these can be found in power plants, for example, or in petroleum industry, refineries, for example, or even in the food industry. And the condensate is removed from one row to another due to a gravity effect as well. And there are many ways to predict the condensate heat transfer coefficient for tube bundle, but it depends on the physics of that process because sometimes you may find um, some gases in the vapor where these gases are not condensable. And we may find many correlations in the open literature for such process. I will give some details in the next part of this episode to describe the process of condensation, heat transfer, and how can we predict its value. The tube bank in general has two main tube arrangement in the bundle, the triangular one and the square. And the triangular is usually at an angle of 30 degrees and it could be rotated to have the shape on the figure top right side. And usually it is rotated to have an angle of 60 degrees. These two types are preferred in tube bundle where we can have higher heat transfer coefficient when compared to other arrangement, and we may accommodate about 15% more tubes in the same size of the shell, and this arrangement is preferable where a clean surface, that is, the fouling effect or the scale is very low, or we can use a chemical cleaning. At the bottom, we have a square where it is arranged in 90 degree or rotated to have an angle of 45 degrees. And this type is usually has low shell side heat transfer coefficient, and of course that will accompanied by a lower pressure drop on the shell side and mechanical or chemical cleaning can be used. These four arrangements can be used in condensation or in the design of condensers of the type shell side or even in the um, what is called a surface condenser such that used in power plants. And now, my friends, we have arrived at the final part of or section of our episode. That is the closure. We passed through the concept of condensation process, and we explain the process on both a single horizontal tube and a tube bundle in the horizontal orientation. In the second part of this subject, I will cover some correlations and I will take a practical application from the industrial field of condensation on horizontal tube bundle. We have some valuable resources and you may find them in a link uh, seated in the description box below this video. And please, if you find the content of the present video are useful to you and others, please subscribe and share the information with your network. I will see you in the next part of this subject. Bye bye.